Hello, Dan here from howtomechatronics.com. In this video, I will show you how I built this Arduino-based RC airplane. Also, I will show you how to control the airplane with this Arduino RC transmitter that I built in one of my previous videos. So, the airplane is entirely made out of styrofoam. For making the shapes, I used my Arduino CNC foam cutting machine, which I already showed you how I built it in a previous video. Although I'm using a CNC machine for building this Arduino RC airplane, I can still say it's 100% DIY because the CNC machine is also a DIY build. Moreover, the control of the airplane is also 100% DIY. Based on Arduino and the nRF24L01 module for the radio communication. Using the right joystick of the transmitter, we can control the ailerons and the elevator of the airplane, and using the left joystick, we can control the rudder and the throttle. In addition to that, using the right potentiometer, we can adjust the control's responsiveness or reduce the amount of servo travel. And using the left joystick, we can sub-trim the rudder or adjust the neutral position of the servo arm. Oh, and I almost forgot to mention, the main feature of this Arduino RC airplane is flying. So yeah, it can fly. Nevertheless, before I start explaining how I built this Arduino RC airplane, I would like to give a shout out to JLC PCB for sponsoring this video. JLC PCB is a manufacturer of high-quality PCBs, which are used in many industries, for prototyping as well as DIY projects. Once you have your PCB design ready, simply upload the Gerber file, review your PCB in the Gerber viewer, select the properties that you want, and order your PCB at a reasonable price. If it's your first order from JLC PCB, you can get up to 5 PCBs for only $2. I started by designing the airplane using a 3D modeling software, Fusion 360 in this case. I made the design by looking at some commercial RC airplanes and following some basic guidelines or rule of thumbs for model airplane parameters. The starting point is usually the wingspan, and I chose to be 80 centimeters. From there we get the fuselage length, which is generally 75% of the wingspan. As for the airfoil, or the wing cross-section, I chose the Clark Y airfoil, which is a popular choice for RC airplanes. I downloaded the airfoil shape from airfoiltools.com as SVG file and then I imported it into Fusion 360. I adjusted the size appropriately so that the wing chord, or the length of the wing in streamwise direction, is around 1/5 of the wingspan. The horizontal and the vertical stabilizers are also sized according to those basic guidelines, and I will include all these parameters in the website article in case you want to design your own airplane. Also, I will include the 3D model of this airplane so you can download it. The link to the website article is in the description of the video. The fuselage of the airplane will be made out of two 10mm sides and a 50mm core, which will be hollow to accommodate the electronics. Now, as my Arduino CNC foam cutting machine work area is limited to 45 cm and the fuselage is 16 cm in length, I had to make the fuselage out of two parts. So I cut the fuselage at 34 cm from the front point and made a new sketch in which I projected the shape and added a point near it. Next, in the manufacturing tab of Fusion 360, I can generate the G-code for cutting the shapes. Here, first I made a new setup where I selected the sketch as a model, selected the point I added earlier as origin for the setup, and adjusted the X and the Y axis appropriately. Then I chose the 2D contour operation and selected or generated a new tool with diameter of 3mm because that's the approximate size of the cuts that the hot wire makes when passing through the styrofoam. Here we can also set the cutting feed rate, which depends on the hot wire itself and the hardness of the styrofoam. I set it to 150 mm per minute. Then in the Geometry tab we can select the contour or the shape that needs to be cut. As for the heights, I set all of them to 1 mm as there isn't any z-axis movement on my foam cutting machine. Lastly, in the linking tab, I selected the entry position to be the edge located near the origin point. With this, the toolpath is generated and we can take a look at it by clicking the simulation button. The toolpath should be a closed loop single pass, and if that's the case, we can finally generate the G-code. For that, we can go to Post Processes, select the Gerbil firmware, select the output folder, name the file and click the Post button. Then we can save the file and we can see the G-code in the WordPad editor or something similar to it. So once we have the G-code file, we can load it in the universal G-code sender and send the G-code to the CNC machine to make the shape. We can note that the process that I have just showed you is probably not the best one, or not professional at all, but still it does the job for getting the G-codes to work with my DIY CNC foam cutting machine. Of course, for more details about this DIY CNC machine, you can check my particular tutorial for it. The link is in the description of the video. So here are all the styrofoam pieces I cut with the CNC machine. 3 pieces for the front, 3 pieces for the back and 3 pieces for the wing. Now I can start assembling them. I will start with the front part. I am using a glue gun for gluing the pieces together. The hot glue was melting a little bit the styrofoam, but still I was able to glue them using this method. Another good way to glue styrofoam is using 5 minutes epoxy. Before gluing the other side, I will make the holder for the motor. For that purpose I am using 30 mm wide aluminum profile, which is pretty lightweight. I cut the profile at around 18 cm, marked the holes for mounting the motor and drilled them using 3 mm drill bit. Then I bent the profile at 90 degrees. I secured the motor to the holder using some M3 bolts. Using this assembly, I made a hole through the front part of the styrofoam. Then, using a utility knife, I enlarged the hole to 30 mm in diameter, as same as the motor diameter. Next, on the other side of the motor holder, I made 4 holes which will serve for securing the holder in place, and also for attaching the landing gear. I marked the location of these holes on the fuselage, and using a 4 mm drill bit, I made holes through the styrofoam manually. I made another aluminum piece around 7 cm long with the same holes, and now I can use it for securing the motor holder. Using M4 bolts, we can easily secure the motor holder in place without damaging the styrofoam. However, I will do that later, so I removed them and continued with gluing the other side. Using the same method, I glued the back pieces as well. Okay, so the next step is the marriage, or connecting the front and the back part of the fuselage. In order to make the connection stronger, I will add a simple barbecue sticks in between them. I would suggest using even some bigger sticks, because when the airplane will crash, it might easily break here. I added some decent amount of hot glue to the connection side and squeezed them together. So here it is, the fuselage is ready and I think it looks pretty cool. Next, using a utility knife, I am cutting 2 pieces of 10 mm thick styrofoam, which will be the horizontal and the vertical stabilizers. I beveled the edges so they look better and also be a bit more aerodynamic. The stabilizers will be directly glued to the back side of the fuselage, but before I do that, I will first make their control surfaces. For that purpose, I cut around 1/3 of their length, and that will be their control surfaces, or the elevator for the horizontal stabilizer and the rudder for the vertical stabilizer. In order to be able to hinge the control surfaces on the stabilizers, I needed to bevel their contact surface. Again, I did that using a utility knife, and we actually need quite sharp one for getting these clean cuts. I continued with making the stabilizers a bit more aerodynamic. For that purpose, I used sandpaper and made their leading edges rounded. I also sanded the trailing edges a little bit. Now, as the styrofoam is quite fragile, I'm going to wrap the whole area of the stabilizers and their control surfaces with a simple packing tape. This will not only make the parts stronger, but also increase the aerodynamic, as the tape is much smoother than the styrofoam itself. After wrapping it, I cut the rudder bottom part at 45 degrees in order to make space for the elevator to be able to move freely. Now finally I can make the hinge for it, and I am doing that using the packing tape again. So I just connected the two parts together with the tape, and that makes quite strong hinge. I repeated this process for the horizontal stabilizer as well. For making the hinge even stronger, we can also add tape on the other side. Using the same tape, I wrapped the sides, and with that the two stabilizers were done. I moved on with gluing the horizontal stabilizer to the fuselage using a hot glue. For securing the vertical stabilizer, first I inserted and glued 3 barbecue sticks through the horizontal stabilizer and the fuselage. Then I put some hot glue on them and the contact surface and pushed the stabilizer down firmly. With this we are done with the stabilizers, and now we can move on with making the wing. As I already said, the wing will be made out of 3 pieces, because of the limited area of my DIY CNC foam cutting machine. Again, I am using barbecue sticks for providing additional strength when gluing the pieces. For attaching them precisely in line, I am using a straight wooden strip on which I can slide the pieces. Once done with that, the wing is actually quite fragile as it's long and thin. Therefore, I will reinforce it by adding a wooden stick to it. I cut the stick to size and mark the wing where I need to make a pocket so I can fit the stick in it. Using the utility knife, I slowly and carefully made the pocket. I added some hot glue to it and secured it in place without disturbing the airfoil shape too much. Although stronger, it would still easily break apart if it hits the ground, so therefore I will wrap it all with the packing tape, as same as I did with the stabilizers. I started adding the tape from the back side or the trailing edge of the wing to the front side or the leading edge. In this way the incoming air from the front won't tend to detach the tape. Although this process looks pretty easy, it can be a bit annoying if you don't have steady hands and enough patience. Nevertheless, I think the wing came out just perfect. Now it is much stronger, more aerodynamic, and it looks quite good. Okay, the next step is making the control surfaces of the wing, or the ailerons. I'm going to make them 22 cm wide and about 1/5 of the wing chord in length. In order to be able to move freely, I cut off like ½ centimeter of it. And of course I wrapped all edges exposed with the cutting with the tape. Next I beveled the bottom part of the aileron at 45 degrees, and in the same way as shown earlier, now I can hinge it to the wing. In order to fit on the fuselage and be able to easily attach the wing on the fuselage, I had to make one more recess in the middle of the wing. Next, it is time to install the servo motors for controlling the ailerons. I'm using the 9 grams micro servos. I marked the location where they will be placed, and using a utility knife I carefully made an opening in the wing so that the servo can fit in. Meanwhile, I removed the mounting brackets of the servo. I put some glue on the servo and inserted it in the opening. Then, using a utility knife, I made a small groove from the servo to the center of the wing so that I can fit the servo wiring in it. Finally, I covered everything with a piece of tape. I repeated the same process for the other side as well. I continued with making the control horns. I'm going to make them out of the aluminum profile that I used before for making the motor holder. I draw the shape by hand to approximately match the servo motor horn height and to hang over the hinge point. I cut the shape using a hacksaw. I will use 2mm steel wire as control rod, so I made an opening in the horn using a 2.5mm drill. I made a small groove in the aileron and glued the horn in place. Then I measured how long the control rod should be, and I made it out of 2mm steel wire with the help of some pliers. We need to note that when measuring and inserting the control rods, the servo motors needs to be in neutral position. We can do that manually by placing it in the middle of its motion range, or by connecting it to a servo tester, or do that with an Arduino. I repeated this process for the other side, and with that the wing is now completely done. Next I need to install the servos for controlling the rudder and the elevator. I'm using the same 9G microservos here as well, and the process of installing them is actually pretty much the same as I have just explained. First I marked the location, made the opening using a utility knife, and glued the two motors in place. Here they are placed next to each other, but their output shafts are on the opposite side. Again, I made a small groove in the fuselage in order to conduct the servos wiring to the electrical compartment. I covered the servos with a piece of tape and made openings for the servo horns. In the same way shown earlier, I made the control horns and glued them in place using a glue gun. Lastly, I made the appropriate control rods and installed them accordingly. Okay, so next I'm going to install 8mm wooden stick which will serve for securing the wing to the fuselage. I made the holes manually using a 6mm drill bit. The rods should hang over around 1 cm on both sides. I secured them to the fuselage using some hot glue, and here's how they actually work. We use rubber bands for securing the wing to the fuselage. In that way the wing can be easily removed, and in case of crashing, the rubber bands will significantly reduce the impact of the wing. At the same time, the whole assembly is plenty strong. Next I'm going to make the landing gear. For that purpose, again, I will use the same aluminum profile and wheels made out of styrofoam. I made them using the CNC machine the same way as explained earlier. I made some small grooves on the aluminum profile so I can easily bend it. Here's how the landing gear should look like after bending it. For attaching the wheels to the profile, I will use M5 bolts and an aluminum tube with 6mm inner diameter. The tube is secured to the bracket using the M5 bolt and nut, and on the sides I added M5 washers, so the wheel now can rotate around the tube freely. With the same method I made the wheel for the backside of the airplane. Okay, so now all the components are ready, and before I assemble them, let's take a look at the electronics of this project. So, as I already said, this RC airplane is entirely based on Arduino. Both the transmitter and the receiver are custom builds based on the Arduino Pro mini board. I already have detailed tutorials how the transmitter and the receiver work, so you can check them out for more details. Here I will explain the circuit diagram and the working principle of this Arduino RC airplane and how everything needs to be connected. So the radio communication is based on the nRF24L01 modules. Although it might look a bit complicated, this DIY Arduino transmitter is actually quite simple. It has several controllers, the joysticks, the potentiometers and some buttons, and it constantly sends their data to the receiver. The receiver receives this data wirelessly through the nRF24L01 module, and it outputs appropriate commands to the servos and the brushless motors for controlling the airplane. Controlling servos and brushless motors using Arduino is also quite simple, so therefore this entire Arduino RC airplane concept I think is not that hard to be understood. The brushless motor I am using in this project has a rating of 1000 kV, and it requires 30 amp ESC. The ESC drives the motor and also provides power to the Arduino and the servos through its battery eliminator circuit feature, which outputs 5 volts. And the power for the ESC and the brushless motor comes from a 3S LiPo battery. I added one more thing to this airplane, and that's a simple LED which will indicate if the battery is empty. Using a simple voltage divider, we can drop the 12 volts coming from the LiPo battery to around 5 volts, so we can read them with the Arduino analog input, and so we know when the battery will drop below 11 volts. The receiver still has several free channels, so we can add more features to this airplane if we want, like strobe lights, flaps, dropping mechanisms and so on. Nevertheless, now we can finish the assembly. So I connected everything as explained in the circuit diagram. On channel 1 is the rudder, channel 2 the elevator, channel 3 and 4 the ailerons, and on channel 6 is the LED. I glued the LED on one side and the power switch on the other side. We can note here that the landing gear is attached to the airplane using the 2 bolts on the motor holder. I actually lost some of that footage, so I cannot show you exactly how I did it. In few words, I simply inserted the motor with the holder from this top opening, bolted in place as shown earlier, and attached the landing gear as well. When inserting the holder, I also added some rubber bands so they can hold the battery in place. So once I connected the battery to the ESC, I squeezed everything in. Finally, using the extension cables, I can easily connect the wing ailerons to the receiver and then secure the wing to the fuselage. On the front, I attached the propeller to the motor, and what's left now is to check the CG, or the center of gravity of the airplane. The CG is probably the most important factor whether the airplane will fly well or fly at all. The airplane initially was tail heavy, so I moved the battery to the front and it got balanced. So that's it, our Arduino based RC airplane is now done and we can go outside to try it out. Here's its first try or the maiden flight. Well, that was not so cool, especially after seeing the result of the crash. My conclusion here was that the airplane was still tail heavy and it felt like the motor didn't have enough power. As I didn't have another motor or propeller to try, I modified the nose of the plane to be a bit smaller, moved the motor more to the front so it has better airflow, and also rounded the edges on the front. As for the structure, I reinforced it with some wooden sticks and aluminum profiles that I glued in the inside area of the fuselage. At the bottom of the electronics compartment I made 2 holes, one for the air to escape that comes from the front opening and the other for getting the NRF24L01 antenna outside for having better range. Okay, so here's the second try. Again, almost the same thing, though it felt like it had better airflow or more power now. The fuselage broke again, which tells that this styrofoam is pretty weak for this purpose. I made a new fuselage and this time I used a little bit of duct tape for reinforcing it. Try number 3. It looked promising, but the terrain I have for takeoff is actually not good at all. The airplane started moving to the right, hit the edge of the road and broke again. I repaired it again and this time I wrapped almost the entire fuselage with duct tape. I should have done that much earlier as this gave the right strength to the fuselage and it didn't break even after several more crashes. The problem now though is that after several crashes I broke all 4 propellers that I had, so in this try I'm using a glued propeller. Of course the propeller teared apart at takeoff. I tried with another glued propeller made out of 2 already broken propellers and this time I was actually lucky and the airplane finally took off properly. Well, the luck didn't last so long as the propeller broke again in mid-air. Nevertheless, as this was my first ever experience with flying an RC airplane, I guess I can consider this project successful, as I managed to prove the concept of making an entirely based Arduino system for controlling RC airplanes. Other than that, we can note from the flight that the controls coming from the transmitter are actually too harsh. That's because the joysticks are not good at all for this purpose. They have small movement range and bad response. In order to solve this, I added a feature to the program through which we can control the responsiveness of the controls using the right potentiometer on the transmitter. Also, I added a function through which we can trim the rudder using the left potentiometer. So at the end, let's take a look at the Arduino code of this Arduino based RC transmitter and wrap this video up. The code is exactly the same as explained in the previous video, for controlling servos and brushless motors using the NRF24L01 transceiver modules. Here I will just quickly explain the main functions of the code, and for all other details you can check the previous video. So after receiving the data coming from the transmitter, we use the joystick 1 y-axis value for controlling the throttle of the airplane. We convert the values from 80 to 255 coming from the transmitter into values from 1000 to 2000 which are used for controlling the brushless motor. For controlling the elevator, we use the joystick 2 y-axis value, which we convert to values from 85 to 35. These values directly set the position of the servo motor in degrees. Right next to them we can notice that we have the travel adjust variables, which value depends on the position on the right potentiometer. We actually use that value to decrease the position or the movement of the servo, although the joysticks will go to their maximum position. The same principle is applied for controlling the ailerons and the rudder. Additionally, we use the data from the left potentiometer to adjust the neutral point of the rudder. Lastly, using the analog read function and some math, we control the battery voltage indicator LED. So that's it. I would like to hear your thoughts about this project, especially from you who have experience in building and flying RC airplanes. For those who are beginners and thinking of getting into this, I would suggest to check the FliteTest YouTube channel because it's an amazing resource for learning about this RC world. I will put a link to it in the description. I hope you enjoyed this video and learned something new. Don't forget to subscribe, and for more tutorials and projects, visit howtomechatronics.com.